So you're going to be given it like this. And here's the cool thing. What did we do here? What is this? Didn't I multiply 0.4 times 1? And then add it to 0.2 times 2? So you multiply across, add down, right? So if I multiply this column times that column, what will this column be? X times P of X. Cool? So 40% of my data is 1s. 20% of my data is 2s, so forth. And when I add them up, I get the average. So I really want you to understand why this formula and this process works. It works. Why? Because it does. There. So why do that shit, Jeff? Why not just put it all down and do it like this? That was a lot quicker. Because what if they give you, oh, let me write this down. So here's the mean, which is, oh, before I do this, what's the formula for the mean then? What did I add up to get the 2.3? I did the sum of what? So the mean formula is the sum of x p of x. There you go. There's your first little formula from chapter 5. The mean is you add up the x's and the p of x multiplied. Right? Okay, cool. So, what about this? Let me ask you this one. Let's say we have 500 adults surveyed. And we ask them, how many email addresses do you have? Cool, is everybody cool with that? So for example, how many email addresses do you have? 2. 1. 1, okay, and so forth, right? So how many people have, anybody have 3 email addresses, possibly? See? Okay, okay. So let's say this is how it comes out here. Can somebody tell me, give me an interpretation of a part of this? Like what does this row here mean?
How many email addresses you have?
Be more specific. What does that row there mean physically? Percentage of what had what? I love it. There you go. 21% of the adults I talked to had 1 email address. Is everybody cool with that? You guys see that? So what's the probability that I would pick an adult out of here that had 1 email address? 21%. That question is stupid easy. Don't let it be hard. Let's probably get somebody that has 4 email addresses. 10%. Let's probably get somebody that had at least 1 email address.
23%.
1 minus none. 1 minus 0.02, right? Or you could just add all these up, but what do you get when you add all these up? Of course you get 0.98 because all these together are supposed to make 1. Do you see how silly that at least 1 and none is? Of course these have to add up to 1 or else I left somebody out, right? So as long as I didn't leave somebody out, if I want all of these, I can just do 1 minus this. Because then these have to add up to the rest. Of course they do. So probably at least one will be 1 minus probably none. 1 minus 1 or 2, 98% chance people had at least 1 email address, right? And now do you see why I don't want to make a list like this? Because how many people would that list have? 500. And how many would have no email addresses? How many of them have no email address? Not 2%. 2% of what? 500. So how many of them have no email address? What is 2% of 500? What is 2% of 500? 10. You guys with me?
Yes.
Where did that 2% come from? They had to ask, do you have an email address? They must have gotten 10 people that said, no, I don't. Because 10 divided by 500 is 2%. That's where it came from. Right? So if I made a list, I'd have to have 10 zeros, 105 ones. All right, I'm already decided I don't want to do that. Right? So that's why I want a quicker mathematical way than this to do it when it's given to me like this. So how do I find the average number of email addresses? what do? What's my my formula now when it's in this format? Yeah. Realize this is the same formula as before, because what's on the bottom of a probability? What's on the bottom of a probability? Total number, right? And don't you sum up the things and divide by how many there are? And that's built in there. Right? This formula is the same as it used to be. It's just a different format to match the way they gave it to me. Cool? Okay. See if you... Oh, cool. He's good. All right. What was I about to do? Oh, yeah. So now that I know that that's my formula, I need to get those so that I can add them up. So how do I get those? I just have to multiply across. So 0, 0.21, 0.68, 0.99, and 0.4. Add those up, what do we get? 2.28. 2.28, right? Something like that? Yes. Cool. I have all the answers right here. All right. So, whenever I have a set of data, if they give me the set of data like this, what are the two numbers I want to calculate to tell somebody so I don't have to show them the whole list? We already did one of them is the mean. What's the other one? What's the other thing we can calculate from a data list that helps me figure out what it looks like? I can calculate the mean and the better than range, better than mid-range. Standard deviation, how spread out it is. So I want to know where is it centered and how spread out is it, right? Because then I can figure out what unusual values are for one thing. And later we'll be able to figure out probabilities for any normal curve or stuff like that, right? So we're going to do later. Okay. So I need to figure out how do I do standard deviation when it's in this format. And the short answer is you do it the same damn way. You just have to use these as a weight. Let me show you. See if I can kind of cut through some of the clutter. So the mean is sum of x p of x. That's one thing. The standard deviation used to be I would sum up this here, right? And then divide by n. I'm talking about a population here. Cool? So I divide by n. But just the same way here, I didn't have to divide by n because it was built in there. Don't have to multiply each of these by their weights. 0.4 times 1 plus 0.2 times 2 and so forth. So if I do this, I've got to multiply each one of these by their weights also. So you might think, that's not the same equation as it was before because the over n's missing, but like I just said, what's on the bottom of a probability? N. So it's built in. So that's exactly the same formula as it used to be. I really want you guys to get that. So I'm trying to kind of cut down some time. Let's do this. Let me just copy this down real quick. 0.4, 0.2, 0.3. So now if I do one more column here, x minus the mean squared. So what's x minus the mean here? It's going to be 1 minus, what was the mean? It was 2.28. You guys with me? So I can do 1 minus 2.28 squared times the probability. Times the probability. And I can do that all the way down. 2.3. Oh, the 2.28 was... What was that one from? No, that's the one we're working with. Oh, did I? Oh, I copied the wrong one down. I'm trying to save time, and instead I make it worse. Over there, this is the set of data I'm working with now, right? I got two sets of data up there, but I'm working with this one right now. Yeah, okay. So here's this, you can see that over there. Here, same thing, so I do 0 minus the mean squared. But the same way that I can't just add these up and divide by n, could I? I had to multiply it by the weight, by the probability of that, right? That's why the average here came out to be 2.28, because do you see how this is weighted heavier than this side? I want you to get this. This is weighted heavier than this is, isn't it? So wouldn't it lean in this direction? Wouldn't it like pull it up higher than normal? So that's why it's not 2, it's 2.28. This was heavier weighted than this, so it pushed it that way, like two people on a seesaw, right? There's the old fat dude over there, guess what? It's going to go that way, right? This guy's a lot bigger. It's going to push that way, 2.28. So here I can't just take the difference. I can't see the deviation by itself. I have to multiply it by the weight. Same reason. Because what percentage of my data is this far away? 2%. So 2% of that. And you can do that all the way down, right? Does everybody see that? You can do that for each one. You with me on that?
Do you adapt to the
Yes, that's the times. Yeah. Yeah. All right. And then this one would be 1 minus 2.28 squared times 0.21. Right, let me just do this. 2 minus 2.28 squared times 0.34, because that's the probability of that. Right? 34% of my data would have this deviation. And so forth. Are you guys with me? And you can add that up and that would be it. But I'm going to show you a better equation for this, because that's kind of ugly. So I agree with you. Some of you guys are already turning it off. I can see it because that is kind of ugly. So here's a better equation. So here's the equation I've got to work with right now. We're not in a summation class. We're not learning about summation symbols, thank God. That would take forever. You could do an entire year on that. So I'm going to show you a couple steps, and I'm going to skip a lot of work and show you what it looks like at the end. So what would you do with that if you were in algebra class? What could you do with that? No, you can't square root it out of nowhere. Foil it. Right? So it'd be x squared minus 2 mu x plus mu squared. Right? I mean, if you foil that bad boy out, when you get x squared, then minus mu x, or minus 2 of them, blah, blah, blah. Right? And then what would you do with this? Couldn't you distribute this through? What's the matter? Write it out twice and foil it. Hopefully you'll get that, or else you should go back and review algebra. So if you do this, if you distribute this through, now here's where I'm going to start skipping some steps, because you see it gets ugly. Because what is mu? Isn't that sum of x times p of x? You could throw that in there and then start messing with that crap. So it actually comes out kind of nice at the end, thank God. It's looking pretty damn ugly right now. But you see the very first term? You guys see where that came from? It just came from x squared times p of x, right? You guys see that?
Yes.
Okay, cool. Now, believe it or not, all this other mess boils down to this. I don't care if you believe it or not, it does, right? If you really want to try it, you would actually have to plug in there what mu is and multiply stuff out, get it all together, you get a lot of stuff that cancels, and you eventually end up here. So this is the formula for the variance, right? Because what have I not done yet that would make it a standard deviation? Square root it. Okay. So coming back over here. I don't envy you guys your notes for this, but do you see how that makes this better now? I just need one more column and a very direct column. What does this formula require from me? To sum up what? X squared p of x, right? Cool? Now let me see if you guys can get this. I have like no time, that sucks.